Welcome back, folks. I hope you guys all had a great holiday break. I will not be back at school until Friday, so until then, you guys are going to watch a series of videos and take notes along with the videos. At any time you guys need to catch up, just ask the sub to please pause the video and take the moment to go ahead and catch up on your notes and everything. You can also go back and watch this video as many times as you want at home. Or on your cell phones. The YouTube link will be up on the board. Hope you guys all had a great break. Again, whether it was eating food or spending time with your family or playing video games, whatever it was, I hope you guys all had a good time and a good break. Let's go ahead and jump back into what we were working on at the end of the semester, which was systems of equations. And the reason we were doing these systems of equations was to find the intersection points of two lines. And we've just been dealing with lines so far, but you can use systems of equations to find the intersection of really any function you want. Maybe later in our math careers we'll deal with a parabola and a line, and we'll try and deal where the intersection points are. Which is a little more entertaining than just lines because, look, we have two intersection points here and here. But we're just going to keep practicing with our lines and our systems of equations, just dealing with a line. We ended with substitution. And I'm going to go ahead, or we're going to go ahead, and we're going to do one substitution just to remind us how that went. So we usually talked about having two equations. We'll have a blue one here, and we're going to have this type of pink one right here. And the first step here is to choose an equation, either blue or pink, and solve for the variable. This y here has a 1 in front, and it's positive. So I think the easiest one to solve for is the blue. You could solve for pink, but you'll have to multiply by a -1 to get y truly by itself. So the blue one is set up perfectly for us to just do this. So we're going to add the 2x to both sides. So this will become y equals 2x plus 3. Once you have solved for a variable of y, you're going to take this and you are going to substitute it in for y. That's going to look such like this. You're going to have 3x minus, and we're going to put parentheses, 2x plus 3. And this equals -2. We have now done our substitution. This is why it's called substitution. Now I have some math to do, so I should go ahead and execute that. I have this -1 that needs to be distributed to both pieces inside the parentheses. Once that happens, we'll have 3x minus 2x minus 3 equals -2. From here, we just have some cleanup. So this will become x minus 3 equals -2. And then last step is I'm going to add 3 to both sides. So I'm going to get that x equals 1. Once we determine that x equaled 1, we want to then find out, well, y equals. So I can choose either my blue or my pink equation, and I can plug in x equals 1. I already have this kind of hybrid of the blue one, so why don't I just take it and throw it up in there. This will give us that y equals 2 times 1 plus 3. And this is going to equal y equals 2 plus 3, or that y equals 5. So what I've discovered here is that if you were to graph these two lines, they would meet at the coordinate of 1, 5. This is our solution. Of course, we want to take the time to go ahead and check this. So let's come do a check up here. And we'll throw this just into the blue equation real fast. So I mean, -2 times 1 plus 5 equals 3. we'll get negative 2 plus 5 equals 3, or that 3 equals 3. So this checked off and worked, and we like it when that happens. So let's then look at a different way. If you need to pause, now's a good time to pause and make sure we get this into our notes. All right, so that was substitution. Again, just some review of what we were working on. Now I want to show you guys the same system, but using a technique called elimination. Okay, and in elimination, what we're trying to do is we're trying to eliminate a variable. That's our goal. Okay, so tonight's practice and the elimination packet is pretty much dealing strictly with elimination. What we want to do on elimination is we want to look at the blue and the pink equation, and we want to say, do any of the variables have the same coefficient out in front? The blue here has a negative 2 and a 3. And the y's here both have 1's out in front. Now, one's positive and one's negative, but that's actually a good thing for us right now. And it'll be kind of clarified as we go through this. So, again, because the y's have the same number out in front, that being a 1. Okay? What we want to do is we want to eliminate y. So what we'll do is we're literally going to put an underbar here, and we are going to either add the blue equation to the pink equation, or we are going to subtract the pink equation from the blue equation. Right now, we're set up just to add. If we add the blue equation to the pink equation, the positive 1 and the negative 1 will eliminate the y variable. So let's do it. Let's just put out a plus sign here and add these. We're going to get that negative 2x plus 3x just equals x. You're going to get positive 1y positive 1y plus a negative 1y, which is going to be 0y. And then you're going to have 3 plus negative 2, and this will be 1. If we clean this up, we get that x equals 1, which if we remember from doing it from substitution, that's exactly what we should get. We still need to find out what y is, so let's take this and plug it into either equation. Say the pink one here. This will be 3 times 1 minus y equals negative 2, or that 3 minus y equals negative 2. We'll subtract 3 on both sides. This will give us negative y equals negative 5. But of course, we need to get rid of that negative in front of the y, so let's divide by negative 1, which will give us y equals 5. So by doing elimination, we've discovered that these two lines should cross at 1, 5. So again, we're looking for... when we're looking at these systems, we're looking for two variables that have the same coefficient. We don't quite care yet whether they're positive or negative. That determines something else. So let's just keep doing some more examples here. Okay, here's another system. Again, we have a blue equation that says 2x minus 4y equals negative 10. And we have 3x plus 4y equals 5 as our pink equation. We want to look across these and see which variable has the same coefficient. Let's see, so 2x and 3x, those aren't going to work. But this here, on the y, we have a 4 and a 4, so we can eliminate. Okay, so we're going to draw our line across. And we need to decide, are we going to add or are we going to subtract? That's when the negative or the positive comes into play. We want to see which operation, addition or subtraction, okay? Remember, addition and subtraction are operations. Which operation will eliminate the variable? In this case, addition is going to eliminate the variable. So if we add, we're going to get 2x plus 3x is 5x. Negative 4y plus 4y is 0y. Negative 10 plus 5 is negative 5. If we clean this up, we're going to have 5x equals negative 5. The next step here is to solve for x. So let's divide by 5 on both sides. This will give you that x equals negative 1. We're not quite done yet, though. We need to find out what y equals. So we're going to take this and plug it into either equation, the blue or the pink. It doesn't matter. I'm just going to go with the pink again. It's going to be 3 times negative 1 plus 4y equals 5. This is going to give us negative 3 plus 4y equals 5. We'll keep solving for y. So we'll add 3 to both sides. This will give us 4y equals 8. We still need to keep going. We'll divide by 4 on both sides. This will give us y equals 2. So once again, if we were to graph these two systems here, we would expect them to cross at the point negative 1, 2. Let's do a little bit more. Go ahead and pause if you need to catch up right now. Okay, here's another one. Again, we have a blue and a pink equation. The blue is 3x plus 2y equals 5. The pink here is x plus 2y equals negative 1. So with this elimination business, we're going across and we're trying to see, do any of the variables have the same coefficient out in front? The x's here have a 3 and a x, or so a 3 and a 1. That's not going to work. The y's both have 2's. So we are set up for elimination. So I'm going to put my underneath line here. But now I need to ask myself which operation, addition or subtraction, is going to eliminate the variable. This is positive 2y and positive 2y. So the only way to eliminate this, to make it 0y, is to subtract. So I'm going to put a subtraction sign out here. And we have to be really careful with subtraction. Notice that I do some actions with my tip of my pencil here, okay, or pen. I literally touch the subtraction sign each time I'm doing the operation. So I go 3x minus x. That gives me 2x. And then I come up and I touch everything again to talk myself through it. 2y minus 2y is 0y. And here's where you got to be careful. Again, you're saying 5 minus negative 1. Well, 5 minus negative 1 is actually 5 plus 1. Okay? That's why we have to be careful. There'll be times where we do a negative and a negative. Or sorry, a minus and then a negative. So we have to be careful that we're actually performing the operation correctly. So 5 minus negative 1 is actually 6. We can clean this up now. So it'll be 2x equals 6. Or we're going to get that x equals 3. Once we have that x equals 3, we want to take this and we want to substitute it into one of the equations. I'll just do the pink equation here, and I'm going to say that 3 plus 2y equals negative 1. I'm going to solve for y, so I'll subtract 3 on both sides. This will give me 2y equals negative 4. Now I'll divide by 2 on both sides and get that y equals negative 2. So what this is telling us is that if we were to graph these two lines, we would expect them to intersect at 3, negative 2. Okay? Now this elimination skill, you kind of have to set up the equation for elimination. So at this point, you kind of have to start thinking to yourself, which one do you like better? Kind of write it at the top of your page right now. Do you like elimination or do you like substitution better? Which one seems easier? Which one makes sense? That's really kind of up to you. There's no right or wrong answer here. It's really how you feel comfortable doing these systems of equations. All right, folks, I got one more for you. I kind of realized, we've been doing nothing but eliminating y. It's not always going to be like that. There will be problems where x will be the thing you want to eliminate. So let's go ahead and look at this system right here. Okay, so we want to ask ourselves which variable has the same coefficient out in front. The x's both have 3's. The y's, this is a 2 on the blue equation and a 1 on the pink equation. So it makes sense for us to eliminate the x's. So we'll draw our underneath line. We need to ask ourselves, addition or subtraction will get rid or eliminate the variable. In this case, we're going to need subtraction. And again, I'm going to touch that subtraction sign every time I perform a move. So 3x minus 3x is 0x. 2y minus negative y. This is 3y. Okay, again, a positive minus a negative. That's really saying 2y minus negative y, which we can rewrite as 2y plus y, because a negative times a negative is a positive. Let's see. Then we have 10 minus 22. This is negative 12. Let's go ahead and clean this up. It's going to be 3y equals negative 12. Divide by 3 to solve for y. So it'll be y equals negative 4. We're not quite done yet, though. We still need to find out what x equals. So we're going to take this and plug it into either equation. I'll go the blue equation this time. And I'm going to say that 3x plus 2 times negative 4 equals 10. I'll start to clean this up. This is going to be 3x minus 8 equals 10. I'll add 8 to both sides to start getting that x by itself. This will be 3x equals 18. And lastly, I'm going to divide by 3 to get x by itself. This will be x equals 6. So, what this means is that if we were to graph these two equations, it means they would intersect at the point 6, negative 4. This is our answer right here. Okay? Now, all of these systems that we just did today in the video, they all have an intersection point. However, remember that there will be times where we have parallel lines. Okay? And then there will also be times, and this is no solution. Okay? And then there'll be times where they will be the same line, in which that's infinite solutions. Okay? And the same rules still apply for that, and those rules are written up on the board over to the left. I'm pretty sure I'm pointing the right way. So if you look over there, the same rules apply for knowing if it's parallel lines or the same line. So for the rest of the period, you guys have time to work on your elimination packet. Some of those questions you won't be able to answer yet until you have the next lecture, which will be on Thursday or Friday, depending on what period you are. You also will have homework both nights, so use the class time wisely, folks. I look forward to seeing you guys when I get back. Again, I hope you guys had a great break, and I hope that this video was able to help. I'll talk to you soon.